Hey everyone, and welcome. Today we're going to talk about something we all totally take for granted. That is, until it's suddenly gone, our electricity. So, what's really going on when the lights go out? Let's dig in.
We've all been there, right? You're right in the middle of a movie, or maybe you're wrapping up a huge project for work, and then poof, everything just goes dark. It's so frustrating. And you're always left wondering, what in the world just happened?
Well, to answer that, we have to get a handle on the power grid. And I know, it sounds complicated, like a giant mess of wires. But the best way to think about it, the way we're going to look at it today, is as a massive, invisible superhighway for electricity. And this superhighway, it runs on one single golden rule. And breaking this rule is what causes all the problems. Okay, so let's take a quick road trip on this thing. Step 1, you've got the power plants. These are the on-ramps where the electricity gets generated and enters the highway. Step 2, you've got those huge transmission lines, the giant powers you see stretching for miles. Those are the main interstates carrying massive amounts of power. Then, step 3, you get to the smaller power poles in your neighborhood. Think of those as the local roads. And finally, step 4, your house. That's the exit ramp where you actually use the power. So here it is, that golden rule. It's all about perfect, delicate balance. The amount of power getting on the highway from the power plants has to perfectly match the amount of power getting off the highway at all the homes and businesses, and it has to match at every single second. If that balance is off, even a little bit, the whole system gets unstable. It's like a recipe for a massive grid-wide traffic jam.
So what causes these traffic jams? Well, there are really three main reasons. Let's start with the most common one, something I'm sure you've experienced, a wrecked road.
So what's out there wrecking our electrical roads? Well, the number one culprit is just bad weather. Ice storms weigh down lines till they snap, crazy winds can knock trees right into them, and lightning, well, lightning can just fry everything. Sometimes it's just old equipment that finally gives out. But then there's a cause you might not see coming: animal interference. And you'd be shocked, seriously, at how many power outages are caused by a curious squirrel. They get into a transformer, cause a short, and boom. For the crews that have to go out and fix this stuff, squirrels are public enemy number one. When any of these things happen, it's like a car crash on the freeway. Safety systems automatically shut that section down to prevent more damage. Okay, reason number 2 for a blackout is basically rush hour from hell. It's simply too much traffic trying to use the highway at the exact same time. Think about it like this. On a normal day, demand for power is pretty steady, totally manageable. But then a massive heat wave hits. What does everybody do? We all crank our air conditioners up to full blast, all at once. The demand for electricity just skyrockets, and it puts this incredible strain on the system. Those local roads just can't handle that much traffic. Now, when the system gets that overloaded, the people who run the grid have to act fast. Otherwise, the whole thing could melt down. And this is where we get something called a rolling blackout. It's super important to know that this isn't the grid failing. It's actually the opposite. It's an intentional, planned power cut to certain areas to lower the total demand and save the entire system from a much, much bigger collapse. And that brings us to the third reason. And honestly, this is the most dangerous one. This is what causes those massive, widespread blackouts you hear about on the news. It's called a cascading failure, and it's basically a terrifyingly fast domino effect. And when I say fast, I mean it all happens in just a few seconds. It can start with one tiny thing, let's say a single power line sags into a tree and shuts down. All the electricity that was flowing through it has to go somewhere, right? So it instantly reroutes to the lines nearby. But those lines weren't built to handle all that extra power, so they get overloaded and fail too. And that just starts the chain reaction. Line after line goes down, and the power plants themselves automatically disconnect to keep from being damaged. The whole system just falls apart. And the scale of this can be just staggering. This is exactly what happened during the huge Northeast blackout in 2003. It started with a simple software bug and a couple of overgrown trees, and it spiraled completely out of control, ultimately leaving 55 million people without power. So we have this incredible machine that runs our world, but it can also be pretty fragile. The good news is engineers are working hard to make it way stronger and a lot more resilient. The future is all about building a smarter grid. This smart grid is all about getting ahead of the problem. It uses thousands of advanced sensors to spot trouble the instant it starts, and instead of waiting for a person to flip a switch, automated controls can instantly reroute power around a problem before it has a chance to cascade. In a way, the grid can actually self-heal, containing a small issue before it becomes a massive one. It's also being designed to better integrate renewables like solar and wind, making our whole power supply more flexible and robust.
So the next time your lights flicker and go out, you'll have a pretty good idea of what's happening, whether it's a wrecked road, too much traffic, or that scary domino effect. And as you're waiting in the dark, you'll understand the incredible, delicate dance that's happening behind the scenes, and the huge challenge we all face in making sure our grid is ready for whatever the future throws at it.